Hello and welcome. Today we're going to be looking at systems of linear inequalities in word problems. This is another topic as part of the Heart of Algebra on the SAT math portion. As always, we're going to be looking at 5 questions. We're going to be explaining them and looking at the intricacies of this topic so you can ace the SAT math portion. If you like these videos and found them informative, please be sure to like and subscribe. And with that, let's get started. Question number 1. Prachi needs between 240 and 260 total feet of fenced panels. The home improvement store has 24 short 6-foot fence panels and 28 long 8-foot fence panels in stock. Which of the following combinations of fence panels could she buy? Well, let's think about what we can do here. So, she needs between 240 and 260 total feet of fence panels, and there are 24 6-foot fence panels and 28 8-foot fence panels. So if she got, say, let's look at the first answer choice right here, and let's see what we can do with that. If she got 6 short fence panels, that would be 36 feet, which of course you can use your calculator. This is calculator active, as you can see by the icon up here. And 26 long fence panels, which is going to be 208 feet. 208 feet, which is going to lead us to 244 total. So this one seems to work. So if we do this, then that will fulfill the requirement. All right, let's do the other ones just to be sure. 8 short fence panels is going to be 48 feet. 23 long fence panels is going to be 184. We add that up, we get 232 feet, which does not work. Not enough. And then we look at the next one, 27 short fence panels. 27 times 6 is going to be 162, plus 12 long fence panels is going to be 96. We add that together and we get 258. Right, so this one also works. Let's see why that is. And then we have 30 short fence panels and 10 long fence panels. 30 short fence panels is going to be 180, and 10 long fence panels is going to be 80. So it's going to be 260. So this one also works. So if 3 of them work, how are we supposed to pick one? Well, this is where you need to be really good at reading the question and understanding what the question is saying. This home improvement store only has 24 short fence panels and 28 long fence panels. You can't get more than that. These 2 answer choices have more than 24 short fence panels. So this is impossible. The store doesn't have that. Meaning that the answer choice that does work is choice A right here. That is our answer. And let's move on. Question number 2. Rodolfo wants to determine how best to benefit from his weekly workouts. His goal is to burn at least 3,300 calories per week from jogging and playing soccer. He can burn 700 calories each hour he spends jogging and 6 calories each hour he spends playing soccer. If Rodolfo's schedule permits him to spend at most 3 hours per week playing soccer and at most 5 hours per week exercising, which of the following exercise schedules will allow him to meet his weekly goal? So remembering the lesson from last time when we looked at some impossible scenarios, let's look if we can find any here. Well, the first one says you can spend at most 3 hours playing soccer, and this has 4 hours playing soccer, so this doesn't work. Right, so it's answer choice A is impossible. Second one has 1 hour playing soccer and 5 hours jogging. That's good. The third one also good, and the fourth one is good. All right. So now let's find out the actual. Let's use the inequalities to see what we can do. So 700 calories each hour he spends jogging, so that's going to be 700 J. And 600 calories each hour he spends playing soccer, so 600 S. And that's supposed to be at least, so greater than or equal to, 3,300. So we plug in the first answer choice, we get 700 plus 3,000, 3,700. So that means that choice B works. The second one, we have 3 hours playing soccer, 2 hours jogging. That's going to be 2,100 plus 1,200, which is going to be 3,300, which also seems to work. Third one has 2 hours playing soccer and 3 hours jogging. So actually, let's try. I switched it up. So we have this. So we have 5 hours jogging and 1 hour playing soccer. So it's 3,500 plus the 600, which is going to be 4,100. And then this one works. And then the second one is going to be 2 hours jogging and 3 hours playing soccer, or 1,400 plus 1,800, which is 3,200. So then this one also doesn't work. There's different colors I'm crossing out because the red means it's not possible. The green just means that it doesn't work. And then the last one is 2 hours playing soccer and 3 hours jogging, which is going to be 3,300. I mean, it's going to be 2,100 plus the 1,200, which is going to be 3,300 calories per week, meaning that this one also works. But of course, we can't have 2 correct answers. So let's see what is going on here. Well, we need to read the question again to make sure that we understand, to make sure that we really internalize what the question is saying, right? You need to make sure you get it. It says at most 5 total hours per week exercising, right? From like a usual person, right? We'd probably see like at most 3 hours per week playing soccer, and then you'd be like, oh, well, that means that we spend at most 5 hours jogging, right? Like that's just a logical connection here. But that's not what it is. You have to read the question. 5 total hours per week exercising. And that's why you can't have 5 hours and 1 hour because that's too many. Which means that this doesn't work. So that's all the problem with having 2 correct answers. And now our answer is just choice D, and we can move on. All right, next question, and here it is. Roberto plans to start a new job. In preparation, he decided he should spend no more than 30 hours per week on the job and homework combined. Roberto wants to spend at least 2 homework hours for every 1 hour at his job. What is the maximum number of hours he spent on his job per week? Well, let's see what we can do. So we can define the homework hours as H and the job hours as J. So he wants to spend at least 2 homework hours for each 1 hour at his job. So H has to be greater than or equal to 2 times the amount of job hours. Right? So H is greater than or equal to 2J. So at least 2 homework hours for each 1 hour at his job. And H plus J, the total should be no more than 30. So it has to be less than or equal to 30. Then we can plug in the H is greater than or equal to 2J. And we're trying to find the maximum amount of hours spent on this job, which means that we should find the minimum number of homework hours so that we can maximize the number of job hours. So we can make this equal to right here. Right, we can put the equal sign there. So if H equals 2J, then we can plug in that in here, and we get 3J less than or equal to 30. So J is less than or equal to 10. So the maximum is going to be 10 hours that he can spend at his job, which is answer choice B. And we are done. Let's keep going. All right, next question, question 4. Here it is. Anuak is an engineer planning sound and lighting for a free concert in the park. The concert is advertised with a promise to use no more than 108 kilowatts kW of power. Now, it was determined that the main contributors to power usage are speakers and floodlights use 1.8 kilowatts and 2.2 kilowatts respectively. Anyone must keep within her budget of $3,300. The rental company is charging $75 for each speaker and $40 for each floodlight, which the following combinations meet the Anuak's requirements. So that was a whole lot of work. And we need to figure out how to put that into some equations, some inequalities, and see what we can do. All right, let's look at the money side of things first. All right, so for each speaker, we can say we have S speakers. So there should be 75 S, that's the amount of money we're spending on speakers, and 42 F for the amount of floodlights. That should be less than or equal to her budget of $3,300. Right, now this is calculator active, so pull out your calculator and we can see if any of these answer choices does not fulfill this first inequality that we've written down. All right, so the first one, we have, we end up with the budget being $4,260, so that does not work. It's too much. All right. The second one, we can plug in the 12 speakers, the 54 floodlights, and we add that up, and we get 3,168. So that one is good. That one works for now. The next one is going to be 26 speakers and 26 speakers, and then 13 floodlights, and we add that up, and we get 2,496. So that also works. And then the last one is 38 speakers and 22 floodlights, which is together going to be $3,774. So that is also not going to work because it exceeds the budget. So this goes away. All right. So look, these two answer choices, and we're going to set up another inequality for this time, the amount of power that's being used. So the amount of power we have for each speaker, we have 1.8 kilowatts. That's going to be 1.8 times S plus 2.2 times F. And that should be less than or equal to, because there's no more, than 108 kilowatts of power. And then now we can plug in these things again and see what we get. So the first one, we have 12 speakers and 54 floodlights. And that's going to give us, 140.4 kilowatts. That is not going to work. Now plug in the second one, we get 75.4 kilowatts. This one works. It fulfills both inequalities. So this meets Anuak's requirements, and this is our answer. Let's move on to the last question of this set, and here it is. The change machine in an arcade gives change in the form of 25-cent coins, quarters, and $1 bills. The manager of the arcade would like at least $50 worth of quarters and $100 worth of $1 bills in the machine at all times. Also, the manager does not allow more than $500 in the machine at any time. What is the maximum number of quarters the manager would allow in the change machine? Well, there has to be at least $100, of $1 bills of 1 dB. And there has to be at least $50 worth of quarters. $50 in quarters. And then we have to have less than $500. Less than $500. All right, so, or less than or equal to $500. So we can just write the money has to be less than or equal to $500. All right. So if we have to have, we're trying to maximize the number of quarters, like here. then we want the least number of everything else. We want the least number of $1 bills. And the least number, since it has to be at least $100, the least number is this 100 right here. And since we have a maximum of $500, that means we have $400 left for quarters. Now, $400 in quarters, since there's 4 quarters to $1, $400 is going to be 4 times 400, which is 1,600 quarters, which is answer choice C, and we are done. All right, that is it for this set. As you can see, these questions are relatively simple. We just have to take the words, turn them into inequalities, and then we evaluate the choices they give us. These are the type of questions where you'll usually have to plug in every single one of the answer choices to see which ones will work. But really, it's just a process of elimination, just more elaborate. That is it for this video. Be sure to tune next time when we continue our study of the heart of algebra. I'll see you next time.